Good morning, students. In previous lecture, we discussed about comparator, its type, then a mechanical comparator, its type, then construction working of mechanical comparator. So let's see what is mechanical comparator. So as we know, if we use the mechanical components for comparison purpose, then it becomes mechanical comparator. So in mechanical comparator, first one is dial indicator, dial type indicator. Here gear, pinion, rack, lever, hairspring, plunger, such type of components are used. That's why that comes under mechanical comparator. These all are the mechanical parts. That's why that type of comparator are called as mechanical comparator. Then if we see the construction of our mechanical comparator, so first one, it consists of plunger and having rectangular inner slot, and such slot are called as rack over there. After that, in that rack, the pinion 1 is meshed with each other. Let's see here. After that, pinion 1, so pinion 1 and gear 1 are both are on same shaft, and so as pinion 1 is rotate, the gear 1 also rotate. Next, gear 1 is connect with pinion 2, and again pinion 2 and gear 2 both are lies on same shaft. After that, gear 2 is connect with mesh with pinion 3, and on pinion 3 there is pointer and which slides over calibrated scale. So pinion 3 mesh with gear 3, and on that gear 3 there is a hairspring. So guide is there, so it helps to movement of plunger. Then the pointer slides over calibrated scale, and from that scale we measure that how much amount of difference is there. That is called comparison. So this is all about its construction. So let's see the working of our mechanical comparator. At first, the job, the known standard is kept under the plunger, and from that dial the zero reading is to be set. After that, the standard part replaced by the workpiece, uh, and workpiece placed under the plunger. So due to that, if there is no any changes in the height of object and standard object, then there is no any movement in plunger. But if there is the different dimensional difference between both, after that, so by keeping the object under the plunger, just a minute. By keeping object under the plunger move towards the upward side, and it slides the rack, and that's why the pinion also starts to slide. So as pinion 1 starts to slide, starts to rotate, then gear 1 also starts to rotate. Then gear 1 is meshed with pinion 2, so pinion 2 starts to rotate, and pinion 2 and gear 2 both are on same shaft, so gear 2 also starts to rotate, and it mesh with gear pinion 3, so pinion 3 also starts to rotate. So on that pinion 3 there is a pointer over there. So that's why, due to the rotation of gear 2, pinion 3 starts to rotate and the pointer slides over calibrated scale. Then gear 3 is rotate with the help of pinion 3, and there is hairspring which is used to move or to come back the pointer on its original position. The hairspring is used. So this all the working of our dial type mechanical comparator. Then in that second image, the reading is uh, of our reading is shown of our dial indicator. So in that two divisions, the distance is 0.01 mm. So one division equals to one revolution of main scale, which is equals to 1 mm. So in this way, the reading is to be taken with the help of mechanical comparator. So if we see advantages and disadvantages, so it do not require any external power source. So all the parts are mechanical parts, that's why it does not require any kind of external power source. Then it is cheaper, available at less cost. Then portable, we can move from one place to another place. It is compact in design, and it has linear scale, easy to read. Any unskilled labor can also use it, and easy to handle. So these are the few advantages of our dial type mechanical comparator. Then disadvantage, so scale has limited range. So if we see the drawing, then we indicate that the scale has limited range. Then chances of parallax error, so while taking the reading, there is a chances of parallax error. Then many moving parts, so chances of friction, hence less accuracy. So as we see, there are the mechanical parts, and gear 1 pinion, gear 1 pinion 1, gear 2 pinion 2, gear 3 pinion 3. So all are rotary parts and mesh with each other. So that's why there is a chances of friction and wait a minute, chances of friction, and hence less accuracy is there. And the instrument is very sensitive to vibration. So application, it is used for checking physical parameters like flatness, roundness, parallelism, need for alignment test on machine tools, used for accurate linear measurement, and used for angular measurement. So these are all about our mechanical comparator.